I would like to do a very short lecture video to discuss the requirements for testing population proportion P. Well, simple random sample is pretty very standard requirement. The second one is the conditions for binomial distributions are satisfied, which means number of trials or sample size is known. And P, which is the probability of success, is also remains the same on each trial. And of course, we have two categories: the category of success and the category of failure. And the last one is the trials are independent. Now, the third requirement is these two have to be true. So n times p is greater than or equal to 5, n times q is also greater than or equal to 5. Let's try to make sense of that. And what is p? P is what is being tested. So n is the sample size, and p is the hypothesized percent of success, or the chance of getting a success, or chance of getting a, if you consider tossing a corn, and you can consider the success as the head, failure as the tail. So basically, this will tell you how many successes that you have. So basically, this is the number of successes. Now, for the NQ, because Q is 1 minus P, so Q will be the chance of getting failure. So this will be number of failures. So that's what that means. So in other words, both successes and failures using the hypothesized proportion should be greater than or equal to 5. And why is that? Because when these two conditions are satisfied, then the sampling distribution of sample proportion will have approximately normal distribution. And with the mean, actually what is the mean? Mean will be n times p. What is sigma? Sigma will be square root of n times p times q. Those are the two formulas that we learned back in earlier chapter. So now I actually would like you to take a look at the I'm going to show you the binomial distribution with different n and different p, so that you are convinced that n times p should be greater than or equal to 5, and n times q should be greater than or equal to 5, so that you get some normal distribution here. And why normal distribution? Because the test statistic, this is your sample proportion, this is the hypothesized proportion. When they subtract and divide by its standard, the standard deviation for the difference, that will be the standardized value, which is the z value. Okay, so we need the normal distribution here. Now, so the n is 10, p is 0.5 by default, and you can see that n times p is 0.5, and n times p is 5, n times q is also 5. And take a look at the shape, perfectly symmetrical bell shape, right? So normal distribution. Now let me exaggerate. So I'm going to change p to 0.4. So in this case, n times p will be equal to 4. And take a look at the shape. And if I'm going to draw that, plot that, it begins to look like skewed to the right a little bit here. Okay, so now when we change this to 3, it's more skewed. If you change that to, say, very small p, you see that this is a very strong skew. And you can see that this is very high, and this is going to be quickly dropping, and then of course the bottom number should be further down to 10, and then it's going to be very, very tiny tail here. So so therefore you see that if n times p is less than 5, that will not work. Similarly, if I change the p to 0.9, which means Q will be 0.1. So N times Q will be just 1 in this case. Take a look at the shape. This time will be left skew here, right? Further to the left. Now what if we change this to 100? Okay, let's take a look at that. So in this case, N times P is actually 90. N times Q will be 100 times 0.1, which is 10. And take a look at the shape. It's fairly close to bell shape now, normal distribution. And because these are both greater than or equal to 5. And let's make this 0.95. Okay, take a look at this one. Not as perfect as previous one, and this time MP is 95. NQ in this case is actually 5. Okay, but still it's not very far away from normal distribution. Oh, I know this is not perfect right here, but as an approximation, that works just fine. So that's why this video is created. I want to help you visualize why these two conditions are there.